Assalamu alaikum. Welcome to daily physics lecture. Today in lecture 3 we'll discuss about the series circuit and voltage divide law. Before I start, this is my third lecture and I'm really not feeling well and sometimes I'm feeling upset. Why? Because you are not following the lectures. I'm giving SWs, I'm giving the solution of the SWs, but you are not exactly doing the SW. That's why I am not feeling well for these lectures. Actually, we all are trying to make these times good for us, effective for us. So if you don't follow the lecture or if you don't do SW, then this will be bad for your vacations, be bad for you and your study. So please follow the lectures, do SWs. So let's start today's lecture. So today's lecture is all about series circuit. Series circuit. So we have already studied there are two types of series circuit. One is the simple series and another one is the mainly series circuit. So here you can see that we have a simple series circuit and there are 1, 2 and 3 resistors. How many resistors there are? There are 3 resistors. So at first we will calculate the current flow through a series circuit. Let me tell you, if you remember your secondary levels studies, then you will understand that which thing actually remain constant. Please try to remember which thing remain constant in a series circuit. Is it a current flow or is it voltage? And hope if you try to remember, then you will understand that in a series circuit the current flow remain constant. Why? Let me explain. Current flow means the flow of charge, means electron. Suppose if we know in a series circuit we have only one line which make it a series circuit, and if 10 electron moves from the cell, then all 10 electron will move through the same line. So as you have one line, so how many electron start moving from this cell, it doesn't matter, it will follow the same line. So at different point in this circuit there will be same amount of current flow. So in the series circuit current remain same. So how the question will appear? As the current will remain same, so the current which flows through R3, the same amount of current will flow through R1 and through R2. So question may appear like this. Calculate the current flow through R1 resistance, that means this one. Calculate the current flow through R3 resistance or R2 resistance, that means these or these. Calculate the current through point A. Here as you see that I have point A here. A is a point on the line. So the current which will flow through R1 or R3 will flow through A. And if the question says they calculate the ammeter reading, we know that ammeter reads current flow. So here we have an ammeter. It will also read the same amount of current which is flowing through R1, R2 or R3. Or the question just tells that calculate the current flow. All these question leads to a single answer, and that answer is a single I, current flow. The current flow through R3 will be I, current flow through A, I, current flow through R1 will be I, current flow through R3, R2 will be I, and similarly current flow through the ammeter will be I. But the main question is that how we can get I. In the previous lecture, while first lecture discussing about EMF, I gave you an equation, and that equation is I is equals to E divided by R plus small r. So this is the most important equation for the basics of electricity, and this current is known as the main current. So this main current is the current which will flow through the main line. So here R3 is in the main line, R1 is in the main line, R2 is in the main line, point A is the main line. So for all these resistance or points, the current flow will be I, and we can get I by this equation. We know E is the EMF of this cell. R out is the total equivalent resistance. In the previous lecture, lecture 2, I discussed about R out. R out is the total equivalent resistance of the circuit outside of the cell, and the small r is the internal resistance. It can be given, it cannot be given, and if it is not given, then we will assume that small r is equals to 0. So if the question says anything about the current flow, whatever the point or whatever the resistance is, and if they are in the main line, we can get current flow by this equation. Okay, I hope you understand this part. I'll discuss about a problem later in this video. So let's move into the another part, and that's the voltage divide law. Voltage divide law. Voltage divide law. So few moments ago I told you what remain constant in a series circuit, and we found that current remains same in a series circuit. So now if I ask you another question, as current remains same, what actually vary in a series circuit? The opposite answer, voltage varies. So as in a series circuit current remains same, so obviously in a series circuit voltage will vary. So now question is how to get that voltage, or how the question will appear. Okay, so the answer will come from voltage divide law. So as you already know that in a series circuit voltage varies. So why? In the previous lecture I told you while discussing the EMF that resistance are the voltage consumers. Cell provide potential or voltage, resistance takes that potential from the electron. So as the resistance take the potential from the electron, so obviously from point to point the potential will not remain same, because resistance are about to consume those potential. So here this is a very simple series circuit. We have R1, R2, we have two external resistance, we have a cell and an internal resistance small e. So I will show you how we can get the voltage through different resistance. Here the voltage divide law says that the voltage used dropped or voltage difference, the voltage used by suppose R, a particular resistance, voltage dropped at R, a particular resistance, or similar question, voltage difference through resistance R or between two sides of the resistance R. These are the same question and answer will be same. So let me repeat. Voltage used by a particular resistance, voltage dropped at that particular resistance, or the voltage difference through that particular resistance or between two sides of the particular resistance. These all will give us same answer. And the answer is, suppose the question says that the voltage used drop or difference through resistance Ri. R small I, subscript I may be 1, I may be 2, I may be 3, I may be 100, doesn't matter, it's the number of resistance. So Ri, suppose that voltage is Vi, the voltage used by Ri. At the bottom you have to write R out plus small r, you have to multiply E, that is the EMF, and at the top voltage used by Ri, Vi, so you have to write here Ri. So for Vi you have to write here Ri. So that's the voltage divider. It's a little confusing, right? So if I give you an example that will be more clear. So let's discuss about an example. Suppose for this circuit, the question asks for us voltage used by R1. Obviously the question will not tell you R1, they will give you some value, but here voltage used by R1. At the bottom, R out plus small r will multiply E. So voltage used by R1, suppose it's V1. So what will be V1? V1 is equals to, at the bottom, R out plus R multiplied by E at the top. For I, we have here Ri. So for V1, we have to put R1. For VI, we have to write Ri. For V1, we have to write R1. So similarly, the question appears as voltage used by R2. Suppose it's V2. Then V2 at the bottom R out plus R into E, and at the top here V2 we have to write R2. So if the voltage used by suppose R coconut tree, V coconut tree will be at the top R coconut tree. Okay, so I hope you get it. For a particular resistance, the voltage used, we have to put that resistance here, and at the bottom the total equivalent resistance plus internal resistance multiplied by the EMF. Now if I say for this circuit, how many thing or resistance will consume the voltage? Now obviously there are two external resistance. We have the voltage used V1 and V2, and there is another resistance, and that resistance is the internal resistance small r. And I told you in the previous lecture, lecture 1, that internal resistance also consumes some potential. That potential is known as the loss potential. So if the question says that voltage used by small r, that is the internal resistance, or loss voltage, calculate the loss voltage, calculate the voltage used by the internal resistance. If these types of questions appear, then V lost at the bottom R out plus a smaller into at the top multiplied by E. So what will we put here? For R2 we have a V2, for R1 we have V1. So for V lost, why the V lost is being used? It is being used by small r. So we have to write here small r. So for 2, 2, 1, 1, and for V lost, small r. I hope you get it. We'll discuss about an XW later. Okay? Now another important thing. If the question doesn't say anything about the voltage used in a particular resistance, rather than they ask you voltage of a particular point, not resistance, remember, voltage of a particular point, then how will we solve it? So voltage of a particular point in a series circuit, how to get it? So it's a very simple series circuit, what we were discussing about. And now, despite of getting potential in a particular point or voltage in a particular point, a particular resistance, let's discuss about a particular point. Suppose voltage at point A, or voltage at point B, or voltage at point C. How we can get it? So that's the law. Voltage, suppose an arbitrary point is X, any arbitrary point. It can be here, 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 anywhere of the circuit. So voltage of point X is defined as Vx at the bottom, R out plus small r multiplied by E. This will be common for all voltage. R out plus small r into E. But at the top, as we are not discussing about a particular resistance, So we can't write that resistance. We are discussing about a point. So for voltage of point X, what will we write at the top? Resistance. What types of resistance? Please very carefully listen and understand very carefully. Equivalent resistance after X, after point X. So X must be somewhere in the series circuit, right? So there will be some resistance in that circuit before X, and there will be some resistance after the X. So we will only take the equivalent resistance which are after point X. Suppose we have four resistors, R1 and R2, R1 and R2, R1 and R2 are before point X, and R3 and R4 after point X. So here what we will write? Equivalent resistance after X. So we will not write R1 and R2, rather than we will write R3 and R4 at the top. Why? After point X there will be R3 and R4. So we will write here the equivalent of R3 and R4. So if I discuss with example, suppose for this circuit we are about to get the voltage of point B. What is B? Try to find it out. Here is B. So that's our B. So VB, voltage of point B, at the bottom R out plus small r into E. This will be common, but what we will write at the top? Voltage after that point, after point B. Here we have the B. So after point B we have how many resistance? We have only one resistance, R2, and we don't have any resistance, okay? So voltage equivalent resistance after point B, this will be only R2, okay? Because after point B we have only one resistance, so equivalent will be for 1. Similarly, voltage at point A, VA, where is Mr. A? Here. And after this point, how many resistance we have in our circuit? R1, R2, 2. So what is the equivalent of R1 and R2? As they are connected in series, so equivalent for R1 and R2, R1 plus R2. So voltage after point A will be R1 plus R2. And if the question say that voltage at point C, what is C? Here is C. So after point C, we don't have any resistance, right? So equivalent resistance after that point, after point C, it will be 0. So these are the way, by this way you can get the voltage of a particular point in a circuit. Okay? Now we will discuss about a problem. Let's discuss about a problem. So here you can see that we have a circuit, and this circuit is a mainly series circuit. Here we have one resistance 6 ohm at the main line, and we have two resistors 12 and 4 mutually parallel. So at first we'll go for the parallel, and then we'll add the series. So basically it's a mainly series circuit. I have already discussed about the circuits in the previous class, lecture 2. So we have a cell here of EMF 10 volt and a resistance, internal resistance of 1 ohm. So there are 3 questions. Question number 1, calculate the current flow through point B. So at first you have to figure out where is point B. Let's find it out. Here, this is the B, and this B is at the main line. This is very important where that point is. B is at the main line. So the current which will flow through point B will be the main current. And how will get the main current? By that EMF formula. Solution of 1. I is equals to E divided by R out plus R. What about R out? The total equivalent resistance. At first we'll go for the parallel. 12 and 4, if you go for the parallel, 12 and 4, the equivalent will be 1 by 12 plus 1 by 4, it will be 3. So here 12 and 4 3, and with this 3 we have a 6 in series. So 3 plus 6, it will be 9. No other resistances here. So R out is 9. Smaller, we have a smaller one. And E, the EMF is 10 volt. So if you put these values, we'll get the main current flow and the current flow through point B. What about the question 2? Calculate the voltage difference through 6 ohm. Why 6 ohm? Here at the main line. So we can get it by the voltage divide law. And the voltage divide law is so R plus small r into E, it will be common, so we will have to put it, and at the top there will be the resistance. So resistance voltage difference through 6 ohm. So for R1 we have put R1 here, for R2 we have put R2 here. So for 6 ohm we have to put 6 here. And whatever R out, 9, smaller 1, and E will be 10. So voltage through 6 ohm, voltage difference through 6 ohm resistance will be 6 divided by R plus 2 to R, small r into E. We can get it. What about question number 3? Voltage of point A, a particular point. What is point A? And we have A point here. So voltage of point A, let's go through the voltage divide law. Solution for question 3. R plus smaller into E, this should be the common. And at the top, voltage for a particular point. Few moments ago I discussed it. The equivalent resistance after that point. So here we have the point A, and after A we don't have anything in series, rather than we have two resistors in parallel, 12 and 4. So equivalent resistance after point A will be the equivalent of this parallel group. So 12 and 4, if you go for the parallel, we will get 3. So voltage after point A, it will be 3. We know R out, we know small r, we know E, we can get VA. So this is a problem regarding today's lecture. I'll give you some other problems as SW. Please solve those problems, and in the next lecture tomorrow, tomorrow I will give you the solution. And please, I have a request to you all, those are not watching this lecture and doing SW, are not doing SW, please watch this lecture very carefully. If you have any problem, please let me know and share it to your friends. Share these lectures through your section group or different college groups, and it's very important to utilize this time. And one more thing important, just don't only watch these videos, please solve these SWs. It's a series of lectures. If you go through these lectures, it will be very helpful for you understanding this part. As we are now in a vacation, so-called vacation, and these are important time, so please utilize it. Study a little daily, some particular moments. We have 24 hours, we can always study a couple of hours. So please watch these videos, do SW, and share it with your friends. If you're not of our college, of other college, please share it to your friends of your colleges and your batches. Okay? So thank you. Do SWs. We'll see you tomorrow. Allah Hafiz.